This is AQA GCSE Coordinated Science Chemistry Higher Paper 1 from June 2018. This is question 7 and it's also an example of a 6-marker question. So we've got lots of information here relating to the solids A, B, C and D. We've got information about their pHs, and that's what I'm going to focus on within this answer actually. But we need to identify each of the solids A, B, C and D, and we've got the 4 different potential compounds down in table 3. As always, this breaks down into a level 3, a level 2 or a level 1 question. And I'm going to start by writing down A, B, C and D and work out which ones I can pick out more easily. So the first thing that I'm going to do is look at the fact that silicon dioxide is totally insoluble. None of it will dissolve. If that's the case, we are going to still be measuring the pH of the water that it's dissolved in, so that it's not dissolved in. So we are going to say that D is silicon dioxide because the pH is 7, and also the solid remains. We can see that within table 2. If I then go to B, I'm considering the fact that phosphorus oxide is a non-metal oxide, and non-metal oxides are acidic. That's the only example of a pH below 7, so that must be the correct answer. And we're then left with A and C. They are both going to make bases. They are metal oxides. Metal oxides are basic. They will make alkalis. So I'm then going to have to differentiate between them by looking at their solubility. And sodium oxide is much more soluble than magnesium oxide. Now that means I'm going to make a much stronger base, which is going to take me to a higher pH. Got the pH of 14, and therefore A is sodium oxide. By default, C is magnesium oxide. Now you can also answer this question in terms of how much solid is dissolved and how much solid remains, but the pH for me is a far more straightforward explanation. Moving on to 7.2, we have got here a pH calculation. Now they don't get more complicated than this at GCSE. It is relatively straightforward. They're simple facts that you have to learn. 10 cm cubed has a pH of B. So what would 1,000 be? Well, we've diluted by a factor of 100, and the pH scale works in terms of dilutions in a factor of 10. So 10 to 100 cm cubed, diluting by a factor of 10, would change the pH from 3 to 4. 100 to 1,000, a factor of 10, would take us from 4 to 5. So our pH is 5.